In lesson 1.2, we talked about the method of substitution. So we solved this linear system by substituting the value of y, which we're told in equation 1 is x plus 5, into equation 2. So wherever we saw a y in equation 2, we just substituted x plus 5 in, because we know that where these two lines intersect, the x value and the y value have to be the same, which means the y in equation 1 is going to equal the y in equation 2, which is why we are allowed to substitute them. So we'll do one quickly, using equation 2, but subbing in the information that we have from equation 1. Now we can use our algebra rules. We're going to distribute this 2 to both terms in the bracket. That's going to give us 2x plus 10 plus x. Now we can group our x terms. 7 equals 3x plus 10. We want to get x terms by themselves on one side or the other. We prefer them on the left, but in this case it's easier to leave them on the right. I'm going to subtract 10 from both sides, which leaves us with negative 3 equals 3x. Now to get x by itself, I need to divide by 3. In order to maintain equivalency, I need to do that to both sides, which leaves us with negative 1 equals x. Now I can use that information, sub it back in one of the equations. We'll go with equation 1 to find the value of y at the point of intersection. So now I know that x equals negative 1, so I can just sub that in for x, which tells me that at the point of intersection, y equals 4. So the solution for this linear system is x equals negative 1, y equals 4. And remember, if we needed to write that as an ordered pair, it would look like this. Negative 1, comma 4. That's x, y. Today, we're going to talk about solving linear systems using the method of elimination. So this was substitution, where we take a value that's equivalent and we substitute it in. Now we're going to be using elimination, and we'll talk about what that means. 1.4. The method of elimination. The 1.4 that you got already was actually 1.3, but the homework was 1.4, I think. Yeah. So the homework was called worksheet 1.4, but it was actually in lesson 1.3. Confusing, eh? So we've reviewed substitution. Today we are starting on the process of elimination. It's just another method of solving a system of linear equations. And we're going to make a little note. The method of elimination is solving a linear system by adding or subtracting one equation to or from, explain that, the other equation in order to eliminate a variable. So the method of elimination is solving a linear system by adding or subtracting one equation to or from, so you add to or you subtract from the other equation in order to eliminate a variable. Review. What is a linear system? So a linear equation will give us a straight line. Yeah, a linear function or a linear equation gives us a straight line. What is a linear system? A linear system involves two lines, okay? To solve that linear equation means to find where the two lines meet, to find the x and y where the two lines will intersect. That's solving the linear system. The linear system just involves two lines. Two lines could be parallel. They would still be a linear system. But if they intersect, we can solve it, okay? So here we go. We're going to apply this to an example. Am I good to clear this? Amy, I'm good to clear? Okay. Oh yeah, okay. Example 1. Example 1, we're given the linear system involving these two linear equations. We are given 1, 3x plus y equals 19, and 2, 4x minus y equals 2. So we're asked to solve it. That means we're going to get a value for x and a value for y. And then we're asked to check our solution. Now, when I look at this equation, I want to make sure that my equal signs are lined up. And if I can, that my x's are lined up and my y's are lined up. What should we do in order to eliminate one of the variables? I can either get rid of x, in which case I'll just be able to solve for y, then use that to solve for x. Or I can get rid of y, solve for x, use that to solve for y. But what I notice here right away is that I have plus y and minus y. So if I add these two equations together, what's going to happen to this plus y minus y? It's going to become 0, and we're going to have eliminated y. So let's do that. We're going to do 1 plus 2. So here I just do it like standard addition. I've got 3x plus 4x, right? I have 3 x's, whatever they are, in equation 1, and I have 4 x's in equation 2. So I have 7 x's. And then I have 1y minus 1y. I have a y minus a y. Well, that's 0. And I have 19 plus 2 equals 21. Okay? You don't need to write this 0 in. I'm just writing it so that you can see what happened. So what we really have here is 7x equals 21. Well, how do I solve for x? I can't minus 7 because these are attached by multiplication. If they're attached by multiplication, I need to divide by 7. And in order to keep my equal sign for this to be a true statement, I need to divide both sides by 7. So these guys cancel out because 7 over 7 is 1, which leaves me just with x on the left. And on the right, we have 21 divided by 7, which equals 3. If you get good at using your general algebra skills and you want to go from this step straight to this step, that is good. That is okay. Yes. Does that answer your question? Yeah. You don't need to write this in every time. But for those of you who still think that you can subtract 7 from this, then you should make sure that you think about it every step. In order to subtract 7 from this, I would have to have 7 plus x. Then I could subtract 7. If I don't have 7 plus x, I have 7 x's. So if I have 7 x's, whatever 7 x's is, whatever x is, I want to divide that into 7 groups, and I only want to take one of the groups. So I need to divide by 7 so that I get one of the x's all by itself. And I can get rid of, I don't need all those other 6 x's. I want to know what one x is worth. So if 7 x's gets me up to 21, then each of those x's must be worth 3. 3, 6, 9, 12, 15, 18, 21. Okay? Okay, what can I do with this value of x now? Yeah, I can sub it into one of the equations. What does it mean to check my solution? How am I going to check my solution? I'm going to sub it into both equations, okay? And hopefully I get the same answer for y. So, yeah, so in equation 1, we are going to have 3 times 3 plus y equals 19. We just subbed in 3 wherever we saw an x. And we can do the algebra on this. 3 times 3 is 9 plus y equals 19. Subtract 9 from both sides. Y equals 10. In order to check my solution, we're going to do the exact same thing in equation 2. If I get y equals 10, then I have confirmed that I have found the solution to this linear system. So equation 2 is 4x, but I'm subbing in 3 for x, minus y equals 2. 4 times 3, because brackets means multiplication, so 4 times 3 is 12, minus y equals 2. I'm going to subtract 12 from both sides. Leaves me with negative y equals negative 10. And now I can multiply both sides by 1. Sorry, negative 1. Multiply both sides by negative 1, which really just takes away the negative sign. If negative, doesn't matter. So if negative y equals negative 10, then positive y must equal positive 10, right? If I have a number line, I have 0, and I go negative 3 is 1, 2, 3 jumps, then 1, 2, 3 jumps this way must bring me to positive 3. So if negative x is this much, then positive x must be this much. They will be the same distance from 0. Does that make sense? Otherwise, algebraically, what's really happening is I'm multiplying this side by negative 1 and multiplying this side by negative 1. I'm doing the same thing to both sides. Well, negative 1 times y is y. Sorry, negative 1 times negative y is y. And negative 10 times negative 1 is positive 10. I've confirmed that this is the solution, and I need to write it as a final statement. The solution to this linear system is, the solution is x equals 3, y equals 10. It did not ask for the coordinates or the point of intersection, so I need to remember to leave my solution in this form. Y equals 10, x equals 3. In example 2, we are going to solve a linear system using the process, the method of elimination again, but it's going to be one more step to solve it. So we have equation 1 given to us as 10x plus 4y equals negative 1. Is this like all the same math, but just different ways to kind of do it? So far we've just done substitution and now elimination. Okay. And equation 2 is given as 8x minus 2y equals 7. And we want to use the process of elimination, which means we're going to try to eliminate one of the variables. But all of my variables, my x's, have two different coefficients, 10 and 8, so I can't immediately add and subtract them. And my y's have 4 and negative 2, so I cannot immediately eliminate the y's. So what could I do? I'm still going to eliminate, but I need one more step in between. Do you remember anything about making equivalent equations that could help us? Could I make a new equation for equation 2 that's actually equivalent to equation 2, but just uses different numbers? How would I do that? Let's just look at equation number 2. I can't. I could multiply the whole equation by 2.
Multiply both of them?
Just equation 2. Well, in the last lesson, we learned that we can multiply every term in an equation by the same value, and it will be the exact same equation, right? That's why you did those equivalent equation homework. Well, let's see, okay? I'm going to take equation number 2. I'm going to take equation number 2. Right, with the last one, we could just go because we had the same number of y's. We had 1y and negative 1y. But here we have 4 y's, and here we have 2 y's. So if I subtracted 4 and 2, I won't eliminate y. Does that make sense? Yes, I could. But the x isn't in this case because I know 2 is a factor of 4. So just watch what happens. We're going to rewrite.
Why are you allowed to multiply but not add? Like, why can't you just add 2 to each thing and then won't it still be the same? Or no?
I could, yep. So I could say equation 2 is 8x minus 2y plus 2 equals 7 plus 2. I added 2 to both sides. This is an equivalent equation, but is it helpful in eliminating anything? Yes. It sounded good. Okay. So here's what's going to happen. I'm going to teach you how to do it, and you're going to do it this way. Okay? Here we go. So we're going to rewrite equation 1. Equation 1 is still going to be 10x plus 4y equals negative 1. But I'm going to multiply equation 2 by 2. So this next line, this next expression, is going to be 2 times equation 2, which means we're going to have 2 times 8x, which is 16x's, 16x. We're going to have 2 times negative 2y, which is negative 4y. And we're going to have 2 times 7, which is 14. So all of the terms in equation 2 have been multiplied by 2. Now, I have an easy way to eliminate my y variables. I have plus 4y and minus 4y. So I'm going to add these 2 equations, and it's going to result in the equation 1 plus 2 times equation 2. So we're just keeping track on this side of what's actually happening. We have 2 times equation 2, and we're adding it to equation 1. Here we go. 10x plus 16x. 26x. 4y minus 4y. Well, that's 0 y's. I'm not going to write 0 y's this time. I'm going to leave it because I don't need it. 0 is no information. And then I have negative 1 plus 14. Negative 1 plus 14 is plus 13, positive 13. And now I can solve for x by dividing both sides by 26. Okay? Well, I'm dividing, right? So 13 divided into 26 pieces. So I have 13 pieces of chocolate, and I'm going to share them with 26 people. So how many pieces of chocolate does each person get? Half. Half a piece of chocolate. Yes. If I have 13 pieces of chocolate and I want to share it with 26 people, I can't hand out 2 to each person. I'm going to run out of chocolate on my 7th person. There's 26 people. Okay? I need to break each of those 13 pieces in half. Right? So that I have half and a half is 1, half and a half is 2, half and a half is 3. And I'll be able to go all the way through my 26 people with 13 pieces if they each get half a piece. So x equals half. What do I do with this x equals a half? Sub it in. Sub it back into equation 1 to find out what y is. 10 times a half plus 4y equals negative 1. Okay, keep up, please. I know that x is equal to a half, so I can just sub in a half wherever I see an x. Because I already found out that x at the solution for this linear system, x is going to be 1/2. You can do it any which way you want. Yes. So yes, could you use this equation and sub in x equals a half and get the exact same y? Yes, because it's the exact same linear equation. It's the exact same. It's equivalent. Okay? So we know that the solution for this linear system is going to be somewhere along this line. X is going to be half. We don't know where our y value is yet, but we know that x is going to be on the line x equals a half. Okay, so now we're solving for the y value. 10 times a half is 5 plus 4y equals negative 1. I'm going to subtract 5 from both sides to get the y term by itself. So this equals 4y equals negative 1, negative 5. That's negative 6. And now I'm dividing both sides by 4, which gets me y equals negative 6 over 4. This is not in simplest terms, though. So I need to rewrite this negative 6 over 4. I can divide the top and bottom by 2, and I can get negative 3 over 2. Okay? This equal sign means that these are the same value. Okay? So if you look on your graph for negative 6 over 4, and you look for negative 3 over 2, you're looking for the exact same spot. There's no difference. Okay? So here's my graph. Negative 1, negative 2. This is the same as negative 1.5, right? Negative 3 over 2 is 1.5. So that point is right here. So now I know that these two lines, if I drew them on the graph, they would intersect right here. That's the solution to the linear system. Okay? On your homework, you will have to throw it into equation 2 and to check if it works. Okay? I already know that it worked, so we're going to carry on. The solution is x equals 1/2, y equals negative 3 over 2. Okay, write your solution down at the bottom. Okay, example 3 asks us to find the point of intersection of two lines. So now I know that my answer is going to be represented as an ordered pair, a bracket xy bracket. Okay, but this is a little bit trickier because I don't see any coefficients, that's the number, the constant in front of the variable, that are the same. So I can't just one step add or subtract right now. And I don't even see any numbers where I can just multiply one of the equations to get the same coefficient in front of either of the variables. So what should we do? We can multiply both of the equations by a constant in order to get a way that we can eliminate a variable. Okay, so for instance, here you have 3 and 4. Well, if we multiply the top one by 4, we'll get 12y's, and if we multiply the bottom one by 3, we'll get 12y's. Okay, but we're going to use the x's in this one. So how would I get these x terms? Yeah, the lowest common multiple of 4 and 5 is 20. Okay, so I'm going to be left with 20x, but I want to get there. What do I have to do to equation 1 in order to get 20 x's? Ness?
Them all by 5.
Thanks, Mel. Times them all by 5. Ness, you got the next one. So equation 1 is going to get multiplied by 5. Go ahead. Do it.
You have to change the last number then too.
Yes. Then it wouldn't be equal, would it? Okay, so we are left with 20x plus 15y equals 5 times 13. You don't need a calculator for that. 5 times 10. Okay, you could do it that way. 5 times 12 is 60 and add 5 more. Or 5 times 10 is 50 and add 15 more. So this is going to be 65. No. Ness, what do we do to equation 2 in order to get 20 x's? Right. I'm going to multiply the entire equation 2 by 4. I have 20x minus 16y equals negative 28.
Now you add them.
Careful, because I have positive 20x and positive 20x. So if I added them, I'd have 40x. I need to subtract equation 2 from equation 1. Yes, that's what makes it challenging. Whichever one gets you to 0. Okay, so we have 20 minus 20, that's 0. And then we have 15, careful here, you have 15y, take away negative 16y. When we're taking away a negative, that's actually adding. Okay, so when you take away a negative, that's adding. So we actually have 15 plus 16, which is 31y. And same thing with these, correct. We have 65 minus negative 28. That's 65 plus 28, and they're nicely lined up for you, so you can use your addition algorithm. 5 plus 8 is 13. Bring the 1 up, and 6 plus 1 plus 2 is 9, 93. Vanessa, how do I get y by itself now? Because here I have 31 times y. I have 31 y's. Yeah, I divide both sides by 31 and find out that y equals 3. So this was a good example because we solved for y instead of solving for x first, which is different than what we've been doing most of the time. You can solve for either variable. Okay, Gavin, how am I going to find my value for x? Good, I substitute y for 3. Could I do it in this equation? Yep. 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 Which one am I going to do it in? Yeah, I'm going to do it in either 1 or 2. Okay, I'm not going to do it. And, well, what's more important is the y value here is negative, right? We're not checking this one. We're solving for x now. So we found y. Now we need to solve for x by substituting y equals 3 into equation 1. Okay, so here we go. Equation 1. 4x plus 3y, but y is now 3. We know that y is going to be 3 at the solution of this linear system. And reduce 4x plus 9 equals 13. Subtract 9 from both sides. 4x equals 4. Divide both sides by 4. X equals 1. Most of the questions that you are asked to do will say, verify your answer, right? Jesus says, verily, verily, I say unto thee. That means truly, truly. It means make sure it's true. Double check it in the other equation. Okay? Verify. Nope. You have found the point of intersection. The point of intersection is 1, 3. Done. Okay, example 4. Do you remember Jumbo Video?
Yeah, we still have it.
No, doesn't exist.
Beer store. Jumbo Video, it's right on whatchamacallit.
No, it's a beer store.
No, it's not.
Yes, it is.
There's still one.
Yes, it is.
Example 4 is a word problem involving linear system, and we're going to use the method of elimination. So, a small store sells used CDs and DVDs. Okay? CDs sell for $9 each. DVDs sell for $11 each. Cody is working part-time. He sells a total of $204 worth of CDs and DVDs. Who can translate that word sentence into an algebra sentence? Cody sells $204 worth of DVDs and CDs together. Okay? Not so tough here. We will let C
You have to write that sentence.
represent CDs. Let D represent DVDs. And I'm going to use lowercase letters. All right, ready? Equation. We have C representing the number of CDs sold, and D represents the number of DVDs sold. So how many items, Nadia, were sold altogether? 20 items. So CDs plus DVDs is 20. That's how much money.
Oh,
So now we can come up with another equation that's going to equal 204, right? So how do I calculate the total value here? Well, each CD is worth $9. So for every C, they're going to collect $9. And for every D, they're going to collect $11. Okay, so $9 for every CD plus $11 for every DVD will equal $204. Good? Okay, I can't eliminate here. What do I need to do? I'm going to subtract one equation from the other one, but if I do that right now, I won't eliminate any of the variables. Okay, so in order to get C or D, in order to get C or D by itself, I need to eliminate either C or D. In order to eliminate, I need to have the same coefficient in front of the D's or in front of the C's. So how do we get that? This is not addition and subtraction. This is multiplication. I could, but then I would be working with fractions. You're right. I could divide. So what Mel is saying is I could divide this term by 11. I could divide this term by 11. I could divide this term by 11. And then I would get an equation that has 1D. Equation 2 would then have 1D. This would be 9 over 11C. And this would be whatever 204 divided by 11 is. Okay? We could do that. And that would work. It's not the easiest way to do it. Okay? So instead of dividing equation 2 by 11, I'm not going to divide equation 2 by 9. I'm going to get the same awkward fractional results as I did dividing by 11. Why don't I just multiply equation 1? I could multiply it by 9. What else could I multiply it by? Could multiply it by 11. All I need to do is get the same number in front of one of these. Okay? So I'm going to take equation 1. I'm going to multiply it by 9. we're going to get 9c plus 9d equals 20. Yeah? Then we have equation 2 is still 9c plus 11d equals 2. Oh, did anyone catch my mistake yet?
You didn't multiply the last one.
I didn't multiply both sides of the equation. 9 times 20 is 180. You have to catch them before I catch them, though.
I caught that one.
I caught that one.
But I was one that.
Okay, so now I have 9c and 9c. Vanessa, what should I do to these equations? Think about it before you answer. I have 9c and 9c. I'm going to subtract. Good, and that's going to give me 0 c's.
Nothing left over.
So I have 9c minus 9c, which is 0. I have 9d minus 11d, which is negative 2d. And 180 minus 204, which is negative 24. Divide both sides by negative 2. Gives me d equals 12. How many DVDs did Cody sell? 12 DVDs. Now he needs to know. Good. So really easy in your head. If he sold 20 items total, then obviously he sold 8 CDs. But we are going to actually sub it in back in equation 1. So we've got C plus D, except D is now 12, equals 20. We subtract 12 from both sides. C equals 8. This one? Because we multiplied equation 1 by 9. So we multiplied 9c, 9d, 20 times 9. That way, equation 1 is still the exact same as equation 1. Otherwise, it wouldn't be equation 1 anymore. It'd be something else. Okay? Cody sold 12 DVDs and 8 CDs. The end. Homework. It's found on page 30, number 1 through 3, 5, 7, and 8. Enjoy.